My dear students, today I am going to discuss for class 11 this chapter permutation and combination. Now before I go to explain and define these two terms, you have to know a very important concept, factorial. Factorial, this is a symbol. Alright. Now 1 factorial is 1. 2 factorial is 2 into 1. Now you note how to read it. 1 factorial, 2 factorial, like that, and this is the symbol. So 3 factorial means 3 into 2 into 1. 4 factorial, that means 4 into 3 into 2 into 1. 5 factorial means 5 into 4 into 3 into 2 into 1. So you see 5 factorial is 1, 2, 3, 4, 5. 4 factorial is 1, 2, 3, 4. 3 factorial is 1 into 2 into 3, all multiplication. So that way, suppose 10 factorial. So I think by now you have understood what will be 10 factorial, that is multiplying from 1 to 10. So 10 into 9 into 8 into 7 into 6 into that way, starting from what? 1. So 1 into 2 into 3 into 4 into 5 into 6 into 7, 8, 9, 10, that is factorial 10. Alright. Now if you see this factorial 10, so as you see factorial 10 is 10, 9, 8, 7, all that. See, it is decreasing by 1, gradually decreasing by 1. So factorial 10 is 10 into this 9. 9 we can write 10 minus 1. 9 is 10 minus 1, then 8. 8 is 10 minus 2. Then comes 7. 7 is 8 minus 3. Sorry, 10 minus 3. Then next 6. 6 is what? 10 minus 4. Then 5. That is 10 minus 5. Then 4. 4 is 10 minus 6. So you see 10 factorial is 10, 9, 8, 7, that way. So 10 into 10 minus 1 into 10 minus 2, 10 minus 3 into 10 minus 4, 10 minus 5, 10 minus 6, 10 minus 7, 10 minus 8. That way it will go on, starting from what? 1. So 1 into 2 into 3 into that way. Now comparing this, we obtain a formula actually. So if you compare like this, you see you will obtain a formula. So what will be the general form? Say n factorial. N factorial. So 10 factorial is 10, 9, 8. So decreasing by 1 gradually. Now n factorial will be n into n minus 1, because you see decreasing by 1, into n minus 2, then n minus 3, n minus 4. So it will go on starting from 1. 1 into 2 into 3 into, that way it will come up to n minus 4, n minus 3, n minus 2, n minus 1, n. So this is the concept of n factorial. So n factorial is n into n minus 1 into n minus 2 into n minus 3 into n minus 4 into n minus 5 into n minus 6, that way, comparing this, starting from always 1. Alright. So this is a concept of what? Factorial, n factorial. Alright. So that way, suppose what will be, now from here we can get another result. You see, suppose you have 8 factorial. Now 8 factorial, how will you write it? 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So 1, 2, 3, 4, 5, 6, 7, 8. So that is factorial 8. All right. Now factorial 8 can be written as this also. So 8 into, now from here to here, isn't it factorial 7? So 8 into this part, 1, 2, 3, 4, 5, 6, 7, we can write factorial 7. So factorial 8 factorial can become 8 into 7 factorial. All right. Now it can also be 8 into 7 into 6 factorial. Now consider up to here. So you see 8 into 7 into this part. Now this part, isn't it factorial 6? So 8 factorial can be written as, you see, 8 into 7 factorial, or 8 into 7 into 6 factorial, or 8 into 7 into 6 into 5 factorial. That means considering taking from here. So 8 into 7 into 6, and this part is what? 5 factorial. All right. So this way, if you compare, then we can write this n factorial. You see, we can write n factorial. This n factorial is n into n minus 1, n minus 2, etc. So we can write n into, what? Yes, you see, n factorial is n into n minus 1 into n minus 2, etc. So from here, if we take this part, so it will be what? N minus 1 factorial. So n into n minus 1 factorial. So this also can be written as n into n minus 1 into n minus 2 factorial. All right. So this can be written as this or this, just like 8 factorial can be written as 8 into 7 factorial, 8 into 7 into 6 factorial, 8 into 7 into 6 into 5 factorial, or if you want to write 8 into 7 into 6 into 5 into 4 factorial, like that. So this kind of exercise will require in doing numerical sums. Okay, I hope this part is clear. Now we go to actual permutation. So this is all about factorial. As I told you, this will be necessary while working out the numerical sums. Okay, now let us see that permutation. Now permutation is just that arrange a few things in proper order. So where the order is important. The main difference between permutation and combination is the difference in the order. Suppose this tree, say this, there are 3 digits, suppose 2, 4 and 9. Now using these 3 digits, you can write numbers 249, all right, or 294, or you can write 429 or 492, like that. Now you see, now each is different. So this is the main property of permutation. In permutation, the order is very important. Now 249 is different from 294. That way 49 is different from 94. 24 is different from 42, because the order is important. But when you go to combination, you will see order is not important. So when you do combination, 49 and 94 same, because 4 is present, 9 is present. So you see only the presence of the objects, not their order. So this is the main difference between permutation and combination. In permutation, the order is very important. 49 is different from 94. These two are different arrangement. But in case of combination, these two will be same, because 4 is present, 9 is present. Again, all these will be same. When you discuss combination, you will see all these are same, because 249, everywhere 249 is present. But when you see permutation, all these 4 are different, because the order is important. Right? Okay. Now let us see this. Suppose you have these 4 digits. So the 4 digits, as you see, 2, 9 and 4. So consider these 3 digits. So let us do it 3 digits, 2, 9 and 4. All right. Now suppose the question is find the numbers. Find the numbers using these three, 2, 9, 4, using 2, 9 and 4. All right. So taking so let us find the numbers. Let us find the numbers using these 3 digits, 2, 9 and 4, taking at first suppose 1 digit at a time. 1 digit at a time. Now taking 1 digit at a time, how many numbers you can 4? Only 3. 2, 9 and 4. Out of these 3 digits, taking 1 digit at a time, how many numbers you can make? 3 digits. So 2, then 9 and 4. All right. Now taking 2 digits at a time. Taking 2 digits at a time. So how many numbers can we make? Let us see. Taking 2 digits at a time. Suppose 29. Then reverse 92. 29 and 92 obviously different numbers, isn't it? So that is the idea of permutation. The order is important. Then taking 9 and 4, 94 and 49, isn't it? Then taking 2 and 4, 24 and 42. So how many we got? 1, 2, 3, 4, 5, 6. So taking 1 digit at a time, how many we get? 3. We get how many numbers? 3 numbers. Taking 1 digit at a time, we got 3 numbers, 2, 9 and 4. But taking 2 digits at a time, how many numbers we got? 6. So we got how many numbers? 6 numbers. Now let us see taking 3 digits at a time. Taking all the 3 digits at a time. Taking 3 digits at a time. So let us see how many we can get. So we get 294, then 249. 2 digits we got. 294 and 249, taking all the 3 digits. All right. Then 924 and 942. So if you start with 2 in the beginning, then 294 and 249. Then 9 in the beginning, 924 and 942. Then 4 in the beginning, so 492 and 429. So again, we got how many? 6. So taking all the 3 digits, how many numbers we get? 6 numbers. Taking all the 2 digits, how many numbers we get? 6 numbers. But taking 1 digit at a time, taking 2 digits at a time, we get 6 digits. Taking 3 digits, all the digits at a time, we get 6. And taking 1 digit at a time, we get 3. So I have shown these taking 3 objects. Now in place of digits, we can consider objects. All right. Now this is the idea of permutation. So in permutation, you have to remember one thing: the arrangement of the objects, arrangement of the digits or objects. So where the order is taken into account. But in case of combination, you will see the order is not important. Simply presence of the objects is important. All right. Okay, now you see. Now this A. Now 1 digit out of 3 digits. Out of 3 digits, we have taken 1 digit at a time. So symbolically, we write this way: 3P1. So note the symbol. So this A will be written as 3P1. Why this 3? Because there are 3 objects, 3 digits, 3 objects. And why this 1? Because we are taking 1 at a time. So 3P1 means permutation of 3 objects taking 1 at a time. Now actually here we got taking 1 digit at a time, we got 3 permutations. We got 3 numbers, so we call them 3 permutations. Here we got 6 numbers, that means 6 permutations. Here we got 6 numbers, that means 6 permutations. So in the first case, we got how many permutations? 3 permutations. In the second case, we got 6 permutations. So each of them is called a permutation. In the third example, we got how many again? 6 permutation. So each of them is a permutation. All right. Now symbolically, this one, this A will be written how? So out of 3, 1 at a time. So we'll write 3p1. So how will you read it? Permutation of 3 things taking 1 at a time. Permutation of 3 numbers, 3 digits taking 1 at a time. All right. So this value we got what? 3. Then this B. So B will be symbolically, it is 3p2. 3p2. So 3p2 means permutation of 3 things taking 2 at a time. Permutation of 3 digits taking 2 at a time. So here we got what? How many permutations? 6. Then similarly this C will be written as what? 3p3. 3p3. So how will you read it? Permutation of 3 things taking 3 at a time. Permutation of 3 digits taking all at a time. All right. So here how many permutations? 6 permutations. So these are symbols, you see. Now, so this tree, you see how this tree we get. Now this tree we can write 3 factorial by 3 minus 1 factorial. So this tree is 3 factorial by 3 minus 1 factorial. All right. Now see this value, 3 factorial by 3 minus 1 factorial. Let us calculate the value and see. Now 3 factorial means what? 3 factorial means 3 into 2 into 1. See, it is 3 factorial. 3 factorial means 3 into 2 into 1. Now this is 3 minus 1 factorial. Now 3 minus 1 means 2 factorial. So 2 factorial. So this is 3 factorial, 3, 2, 1, and this is 3 minus 1 factorial. 3 minus 1, 3 minus 1 factorial. So that is what? 2 factorial. Now 2 factorial means what? 2 into 1. So this 2 into 1 and 2 into 1 cancel. What remains? 3. So you see this 3. So in place of 3, we can write 3 factorial by 3 minus 1 factorial. So actually we are going to get a formula. That is what I am trying to show. In case of 3, what you can write? 3 factorial by 3 minus 1 factorial. 3 minus 1 factorial. And if you calculate this value I have shown you, you will get 3. So 3 can be written like this. Similarly, this 6 can be written as, you see, 6 factorial by 3 factorial, sorry. 3 factorial by 3 minus 2 factorial. 3 minus 2 factorial. So this 6 can be written as 3 factorial by 3 minus 2 factorial. You calculate this and see, you will get 6. So let me show you. So calculate and see. So if you calculate this, you will get this 6. Let us see. Factorial 3 means 3 into 2 into 1. This is 3 minus 2 factorial. That means 1 factorial. 1 factorial is 1. So what do you get? Isn't it 6? So you see this 6. So in place of this 6, what we can write? Factorial 3 by factorial 3 minus 2. So calculating we get 6. You see. Similarly, this one. So this 6 we can write. We can write factorial 3 this 6 you can write how? 3 factorial by 3 minus 3. 3 minus 3 factorial. So you see, this was written as 3 factorial by 3 minus 1 factorial. This is written as 3 factorial by 3 minus 2 factorial. Similarly, this will be written as 3 factorial divided by 3 minus 3 factorial. Now, so in place of 6, you calculate this, you will get 6. So let me show you how. Now 3 factorial. 3 factorial is 3 into 2 into 1. Then 3 minus 3, that is 0 factorial. Now 0 factorial is taken as 1. So this is one very important result you note. 0 factorial is 1. So 0 factorial is considered as 1. Alright. So this part is 1. So 1 and here 6. So 6 by 1 is 6. You see 6. Okay, followed. So 3p1 can be written as this, 3p2 can be written as this, and 3p3 can be written as this. So if you consider these examples, compare these examples, then we get a very important formula. We get a very important formula. So that I am showing you here. So 3p1 is this, 3p2 is this, 3p3 is this. So comparing this, we get a very important formula, NPR. Yes, this is the main formula of permutation. So I am going to write now the main formula of permutation. So NPR. So comparing this, what you can write? NPR is n factorial divided by n minus r factorial. So this is the main permutation formula. So NPR is just like here 3p2 is 3 factorial by 3 minus 2 factorial. Alright. So that way NPR will be n factorial by n minus r factorial. So you see n factorial by n minus r. This is the main formula for permutation. So how will you read it? Permutation of n objects taking r at a time, or permutation of n things taking r at a time, equal to n factorial divided by n minus r factorial. So from now on, the permutation numerical sums you will solve by using this formula. This is the main formula, as I told you, of permutation. Okay. All right. So now let me give you some other less important formula for permutation. Okay. So as I told you, that is the main formula. So in permutation, remember one thing, very important thing, you have to arrange the objects, you have to arrange the digits, but you have to take the order into account. The order is very important. The order is very important. All right. For example, suppose there are 3 seats. Suppose there are 3 seats. Suppose there are 3 chairs and there are 4 students. Now you want to make them sit. Suppose these are 4 chairs. Suppose this is the first chair, this is the second chair, and this is the third chair. And there are 4 boys, suppose A, B, C, D. So these are 4 boys, 4 students, A, B, C, D, and there are 3 chairs. Now you want them to sit. All right. Now see here, A can sit here, B can sit here, C can sit here. So that will be one permutation, A, B, C. All right. Now out of 4, there are only 3 chairs. That means it will be 4p3. We have to we have to find the number of arrangements. That means numbers of permutations. But there are only 3 things. Only 3 students can be accommodated. So out of 4, 3 at a time. So 4p3. Right. Now this is one permutation, ABC. Or ACB, this is another permutation. A can sit here, B and C here, then they can reverse C and B. ABC is different from ACB. As I told you, order is very important. All right. Then suppose A sits here, then it can be B and D, A, B and D. Now here A, B, C, so D is out, but now A, B, D, C is out. All right. Then suppose A always sits here, then it will be A, D, B. Okay. Then suppose now B comes here, suppose B, A, C. B sits here, A sits here, C sits here. Then BCA. So this way you go on and try to find out. But how many such arrangements, how many such permutations will be there? And now we can find very easily using the formula. Using this formula, you see, using this formula, what will be 4p3? 4p3. So n is 4, r is 3. So using this formula, we can find out. So how many ways this out of 4 boys, you can make 3 boys sit in this chair, say 1, 2, 3. So I have shown you 1, 2, 3, 4, 5, 6, and only 6 I have shown, but there are some more. So how many more are there? You can find out using this formula 4p3. 4p3. So factorial, it will be 4 factorial. Using this formula, you see 4 factorial. 4 factorial divided by 4 minus 3 factorial. Isn't it? So 4p3, 4 factorial divided by 4 minus 3 factorial, just like this, and PR, n factorial divided by n minus r factorial. Okay. So now using this formula, we wrote that. Now let us see. Let us calculate. Let us calculate this. So 4 factorial. This is 4 factorial, and this is 4 minus 3, 1 factorial. Now 1 factorial is 1. 1 factorial is 1. So this then doesn't matter. So 4 factorial is what? 4 into 3 into 2 into 1, isn't it? That means 24. You see, this is the answer. So I have shown you only 1, 2, 3, 4, 5, 6. See, there are 18 more. Total there will be 24. ABC, ACB, ABD, that way. Then if you take D here, DAB, DBA, DAC, DCA, that way go on writing, you will get how many permutations? 24. So we have found out by using this formula. All right. Okay. Now suppose this ABCD, suppose there are only 2 chairs. Okay. Now this time let us see. Suppose there are only 2 chairs. 4 boys, but only 2 chairs. Only 2 chairs. Then what will be the number of permutations? There are 4 students, 4 boys, but only 2 chairs available. So suppose B sits here, D sits here. Then D sits here, B sits here. So we got 2. Then suppose A sits here, C sits here. C, A. So this way go on writing. So you will get how many? Let us see. So out of 4, taking 2 at a time. Out of 4 students, we taking 2 at a time. So here B and D taken, here A and C taken. So taking 2 at a time. That means 4p2. So number of permutations of 4 objects taking 2 at a time. Number of permutation of 4 students taking 2 at a time. So using that formula, 4 factorial divided by 4 minus 2 factorial. So using the formula, NPR equal to n factorial divided by n minus r factorial. All right. So let us calculate. So this is 4 factorial. 4 factorial divided by 2 factorial. All right. Now 4 factorial is 4 into 3 into 2 factorial. You see, 4. 4 factorial means 4 into 3 into 2 into 1. So you can write 4 into 3 into 2 factorial. And here 2 factorial. So 2 factorial and 2 factorial cancel. So how many? 12. All right. So I have shown you 4. So that way go on writing, there will be So like that. So 1, 2, 3, 4, 5, 6. There are 6 more. Total there will be 12. So using the formula NPR, we got 4 factorial by 4 minus 2 factorial. That means 2 factorial. So 4 factorial can be written as this way. Then 2 factorial cancel 12. So 12 permutations. So out of 4 things taking 2 at a time, out of 4 students taking 2 students at a time, so how many arrangements you can make? We can make 12 arrangements. So that was the main formula. Okay. Now let me give you some other formula also, which you have to memorize. Okay, so let me write the so main formula is that one. So NPR equal to what? N factorial by n minus r factorial. This is the main formula. Okay. Then NPN is just factorial n. So number of permutation of n things taking all at a time, NPN. Permutation of n things taking n at a time, that means taking all at a time. So straight n factorial. Okay. Then NPN minus 1, this is also n factorial. NPN is n factorial and NPN minus 1, just one less. Suppose here 6p6 is 6 factorial, then 6p5, one less. 6p5 also will be what? 6 factorial. 9p8 will be 9 factorial. 10p9 will be 10 factorial, just one less. Okay. Then NP1 is n. Number of permutation of n things taking 1 at a time. So number of permutation of 6 things taking 1 at a time is 6. Number of permutation of 3 things taking 1 at a time will be 3. That way number of permutation of n things taking 1 at a time will be just n. Okay. Then the one already I wrote before, you see factorial 0 equal to 1. This value you have to memorize, you have to know factorial 0 equal to 1. All right. So these are yes. So these are the 5 relations. This is the main formula. Then from here NPN equal to this, NP this one. So if you know this formula, then quickly you can do sums. All right. Okay, so today then we'll stop here. So I'll continue from here. So meanwhile, using this formula, so try to do a few sums from that exercise of your textbook, class 11 textbook. Try to see how you can use this formula in solving those exercise sums. So next time we'll discuss more permutation and then come to combination. Okay. All right for today. Thank you.